All right, before we get started, you might want to print this thing out. It's in your notes somewhere. I printed it for you. We are going to try and connect everything we've done so far. We've learned about degrees and radians and how to convert from one to the other. And we're going to combine all that on the unit circle, but we're also going to come up with then the ordered pairs of those points on the unit circle. So just a quick review. We've worked on the 45, 45, 90 right triangle, and we learned that the hypotenuse is equal to the leg times the square root of 2. And our other special triangle was the 30, 60, 90. And we had a short leg, long leg, and the hypotenuse. And the hypotenuse was 2 times the short leg. And the long leg was the short leg times the square root of 3. Now we want to put all of this on what's called a unit circle. And a unit circle is a circle with a radius of 1. That's important. Circle with a radius of 1. So if we put those on this circle, it is the 45, 45, 90, and the 30, 60, 90. Knowing that this is the unit circle, then this hypotenuse or radius is 1. And I can find the lengths of these legs. They're going to be the same thing, but I can find them using what we learned earlier, that the hypotenuse is equal to the leg times the square root of 2, because I know that the hypotenuse is 1. It's the unit circle. And substituting in 1 for the hypotenuse, I can now solve for the leg by dividing both sides by the square root of 2. So it'd be 1 over the square root of 2. Of course, we can't have a square root on the bottom, so we learned this before. Multiply the top and bottom by the square root of 2. So that tells me that each leg is the square root of 2 over 2. That means the x is square root of 2 over 2 and the y is square root of 2 over 2, which then gives us the ordered pair at this point on the unit circle. The x is square root of 2 over 2 and the y is square root of 2 over 2. But if we go back to something else we learned that the sine is equal to the opposite over the hypotenuse. So if we're looking at this angle right here with the origin, the opposite would be y. Opposite over hypotenuse, I don't know what I said before. Opposite over hypotenuse, so it'd be y over 1, which is just y. So the sine is your y. So this one right here, this second term here, is the sine. And your cosine is equal to adjacent over hypotenuse. So if you go back to this picture looking at this angle, the adjacent is the x, the hypotenuse is 1, so it'd be just x over 1 or just x. So every ordered pair in the unit circle, the x is the cosine, the y is the sine. So I could ask you, what's the sine of 45? It's square root of 2 over 2. What's the cosine of 45? Square root of 2 over 2. And I can do the same thing on this triangle, because we remember that the hypotenuse is equal to 2 times the short leg. I'll just write short. Okay, but I know in the unit circle, the hypotenuse, or the radius, is 1. So I can put that in there and then solve for short. So the short leg is going to equal 1/2. The short leg is this y value. That's the short. So this ordered pair, the y is 1/2, or the sine is 1/2. Now I can find the long leg, which is my x value in that triangle, by doing the short leg times the square root of 3. But I know the short leg is 1/2. 1/2 times the square root of 3, I'm just going to write that as the square root of 3 over 2. So that is my long leg, which in this triangle is the x. So my x value of this ordered pair is square root of 3 over 2, which is my cosine. So what is the cosine of 30? Square root of 3 over 2. But in this same quadrant, quadrant 1, I can draw a 30, 60, 90 triangle again, but this time the short leg is the x. So I just basically take this ordered pair I have and reverse the order, because the short leg is the 1/2. This one here is now down here. And the long leg is your y. So cosine, sine. So what is the cosine? This angle here is 60 degrees. Cosine of 60 is 1/2. And I can use that to fill in this unit circle. I'm going to fill in some of it. You're going to do the rest. Right now, though, I want to just focus on these angles, which is an old assignment. This is 0 degrees. And if we start with this one right here, this is 30 degrees, and every multiple of 30, 30, 60, 90, 120, 150, 180. I'm not going to go around. You're going to fill out the rest of this. And then we do the 45. The 45 is the one in the middle. Oops, sorry. 45 is the one right in the middle of that quadrant. And every multiple of 45, 45 times 1, 45 times 2, 45 times 3, 135, 45 times 4 is 180. And you just finish the rest of that circle, go around the circle, finish that. Then let's go ahead and look at these right here. These are the radians. And if you remember, we can now convert from degrees to radians by multiplying by pi over 180. And 30 goes into 186 times, so that would be pi over 6. So this radian right here, 30 degrees, is also pi over 6. Now if I do the same thing, just multiples of 30, 30, 60, 90, 120, 150, 180, 1 pi over 6, 2 pi over 6, which reduces to pi over 3, 3 pi over 6, which reduces to pi over 2, 4 pi over 6, which reduces to 2 pi over 3, 5 pi over 6, which doesn't reduce, 6 pi over 6, and so on, 7, 8, 9, 10, and so on. You finish those. That's part of your homework. And then I'm going to take the 45 degree, and change that to radian also. 45 goes into 180 4 times. Okay, so pi over 4 is the same thing as 45 degrees. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and you can fill in the rest of them. That's your job. All right, but I'm going to use the information that we did on those triangles. I'll bring that back. And you see that the ordered pair at 30 degrees, we figured out to be the square root of 3, over 2, and 1/2. And I like to label these cosine sine. All right, and then we also had, if you look here, the 60 degree angle is just the reverse of this because it's the same triangle. So I just reverse the order of those ordered pairs. So this is 1/2 square root 3 over 2. Again, this is cosine, this is sine. So if I ask you, what is the cosine of 60? 1/2. If I ask you, what's the cosine of pi over 3? Still 1/2. Right, and then the 45, 45, 90 triangle, the ordered pair, these legs are the same, square root of 2 over 2. So that goes right in here, square root 2 over 2. But something interesting happens in this unit circle. I'm just using the same angles over and over again. This is a 30 degree angle, so this is a 30, 60, 90. This is a 45 degree angle, so this is going to be related to this ordered pair. This is a 60 degree angle here, so it's related to this ordered pair. Well, this is quadrant 1. And every ordered pair in quadrant 1 has a positive x and a positive y. This is quadrant 2. Every ordered pair in quadrant 2 has a negative x and a positive y, because from the origin you're going left which is negative, and then up, which is positive. So again, something interesting happens here. This is a 30-degree angle. So I'm going to use this same ordered pair here because it's still the same triangle, but now my x is negative, or my y stays positive. So negative square root 3 over 2, positive 1/2. This is a 45-degree angle, so it's related to this over here, this ordered pair. I just take that same ordered pair, I put it over here, but I make the x negative. So negative square root 2 over 2, positive square root 2 over 2. And then this angle here is a 60-degree angle. Because this is 180, this is 120, there's 60 degrees away. So I'm going to use this 60-degree angle over here. It's called a reference angle. And I'm going to use the same ordered pair, but instead of a positive x, I'm going to make the x negative. So negative 1/2 positive square root 3 over 2. And I can do the exact same thing in quadrant 3, in quadrant 4, in quadrant 3. I know that the x is negative, the y is negative. In quadrant 4, going to the right and then down. So the x is positive, the y is negative. You can fill out these ordered pairs also. Here's one thing I'm going to use a lot in this class. All seniors turn crazy. What does that stand for? Well, all of the trig ratios, sine, cosine, and tangent, are positive here. Seniors, sine is positive, your y value is positive, cosine, sine. Here, turn, your tangent's positive, and here your cosine's positive. Okay, so you're going to fill out the rest of those, but how do you find the tangent? Well, remember the tangent is opposite over adjacent. Well, that's just your y value over your x value. So in this case, the tangent is equal to 1/2 divided by square root of 3 over 2, which is 1/2 times 2 over the square root of 3. Well, those cross out. Can't have a radical in the bottom. If you multiply like we did before, you would get this right here. This is the tangent at 30 degrees. Well, this one, the tangent, sine over cosine, any number divided by itself is just 1. This one, the tangent, is sine over cosine. Well, that one I can just flip the second fraction over and multiply, and I just get the square root of 3. And those values of tangent can be used in the other quadrants. Tangent's negative over here, sine over cosine, positive here and negative here. I want you to fill out the rest of the circle, and that's your homework. Oh, one last thing. These quadrantal angles here. If I started the origin and moved this way, and the unit circle has a radius of 1, the x is 1, the y is 0. Here, I move over 0 units to the right, and I go up 1, cosine, sine. All right, now you finish the rest.